I am Brian Fortenbery. I'm with EPRI. I'm a program manager in the energy efficiency and energy utilization area. We have a group of engineers, about 15, that are working in this area. Most of the power quality work that we do is at the low voltage side, so it's the customer side of the meter, 480 volts and less. There's a couple. I think with power quality, we have a 10-year plan in our research area. I left out the fact that EPRI has a lot of research going on that's not related to this, nuclear and generation and environmental. The sector that we're a part of, Bill Howell and myself, is called power delivery. Okay, and so it's transmission, distribution, substations, transformers, and everything all the way down the line. The power quality program is part of that section. And so in power quality, we have a 10-year plan where we have gotten our funders, our utility members, to brainstorm with us, what do you see as your vision for the quality of your power in 10 years? And we worked up hundreds of success statements, and then we defined critical gaps, technical critical gaps that would prevent us from getting there, and then we define our research over the next 10 years to try to overcome those gaps. In my area, it's the end-use area, the gaps or the success statements are to mainly, the main impact is going to be development of standards for equipment. So on the grid side, we hear a lot of talk about standards. We have a lot of standards for performance and indices and so on. On the load side, not so much. There's a few here and there, but probably the best success we've had so far is with the semiconductor industry, where we developed a standard, or we helped to develop a standard called SEMI F47. I don't know if you're familiar with this one, but it defines a ride-through curve for the end-use equipment. As long as that equipment is compliant, it passes the certification, the semiconductor manufacturer can buy it and make sure it's compliant. We have done surveys after the fact that have shown they're saving millions of dollars in potential losses because of the standard. What we're doing now is going through IEEE, and we're going to try, or we have already started to, the process for an immunity standard for electrical equipment below 1,000 volts. So at the end of the 10 years, hopefully, we will have a standard balloted and vetted and accepted by the IEEE. The second area that we are working towards, and this is another thing that we think is a good vision for the future, is an equipment design guidebook. Okay, so this will be designed to be an IEEE recommended practice, and we will develop over the next 10 years the chapters that go in to how to design an electronic device to be immune to all the types of events that we know to be common. And so with the definition of power quality events and with the history of the monitoring programs around the world, now we have very well defined the electrical environment. Now we can define how the equipment should be designed so that it's immune. At the end of the 10 years, hopefully, we have a recommended practice as a standard, and it's going to be a guidebook for designers to use to make their equipment immune. It comes up under the Energy Efficiency Initiative because on a large scale, we want to work with regulators and utilities at the highest levels and talk about the transmission planners and how they can use these efficiencies and these demand response programs as resources. And that's very important, and I think that will have a lot of impact from regulators. But my own perspective comes from work that we've been doing with electronic power supplies. If you consider that most of the devices in the home are powered with a conversion from AC to DC, and if you consider that all the computers in the world are powered the very same way, with a very standard type of power supply, ask what the efficiency of that power supply is. 75, 65%. So we've been doing a lot of work with manufacturers and with policymakers to push for higher efficiencies in those power supplies, just for the computers. The success that we've had is with the EPA, the United States Environmental Protection Agency. They run a program called Energy Star. Energy Star puts a sticker on every device that's compliant with their specification. In the U.S., all the computers 98% of the computers had an Energy Star sticker. That specification was based on, this was 4 years ago, that was based on the fact that they were designed to go into a sleep mode. So they had power management features. 4% of the computers in the United States had that sleep mode enabled, which means they had a lot of market penetration, but it wasn't working. Nobody was using it because it was user-enabled or user-disabled. The user had too much choice in the matter. So this time we looked at the active mode efficiency, not sleep mode, but what is the efficiency of the silver box when it's running? And we were able to find that it was relatively low, and we were able to find ways that were very easy for designers to implement and improve their efficiencies. Today, there are over 130 models on the market, representing over 30 manufacturers. And it's not just the small ones, but major volume manufacturers of computer power supplies that have met the specification that we helped develop for Energy Star. So now in July of 2007, the new specification came out from EPA for Energy Star. And anytime you buy a computer that has an Energy Star sticker on it, it's going to have a power supply that's 80% efficient across the load spectrum, down to 20% load. So it's had a big impact. And we've been able to make a difference with the research that we're doing in our laboratory, but it couldn't have been done without the policymakers. The efficiency programs are almost always policy-driven, or some sort of incentive program driving those. And so what we find is that the policy-making groups need to have valid technical data to make their decisions with. And so what we were able to do is provide them with that basic framework of technical data so they could make informed decisions. And now they've put a specification into place, and the industry is right there with them because they were able to implement the design changes working with us as we went through the process, and it took about 2 years to do it. But now the market is there. The market has responded. The specification is in place, and you can go out and buy an Energy Star compliant computer, and they'll be available because the manufacturers are making them now. All power quality conferences are great. You don't want to miss any of them. This particular conference was very technical in nature, and I found a lot of value in things such as I saw a new power conditioner design that I think would be very valuable. I didn't mention that part of our program evaluates power conditioners on a yearly basis for our funders. We would like to get that new device into our program so that our funders can be aware of the latest and new designs. So to me, that was enough value in that one device for making the trip and coming to the conference. But in addition to that, there are a lot of other technical presentations on how to analyze the impact on the grid of electronic devices, as well as some of the design parameters that people are dealing with. So we saw some higher voltage IGBTs today that I was surprised by. I didn't realize those were readily available. I'd heard people using IGCTs, but IGBTs are not usually that high voltage. So that was very interesting as well. I would advise anybody who is interested in power quality or its effect on the grid to attend this next year. Well, one of the things I noticed is that a lot of the presentations are very technical and perhaps some practical applications would be, there are some, of course, but I think some more of those would be valuable. And of course, my side of the story is more stuff on the low voltage side. I would include more end-use equipment. I know that utilities are usually thinking in terms of medium voltage and high voltage impacts on grids and so on, but I think there's a lot of people that are interested in the end-use loads, and you'll attract a lot of them if you include that.